Hi, welcome to ODC classes. My dear students of class 10, I hope you are preparing well for the upcoming board examination. In order to boost your preparation, in today's session, I am going to give you a simple problem solving technique for the circuits. I'm sure this technique is going to help you immensely in the examination. So let's get started. As you can see here in the screen, there are three circuits given here. My first question for you is a simple one. Can you identify these circuits? I think by now you have guessed it correctly. The first circuit that you see here is a series circuit. The second circuit here is a parallel circuit. And the third one that you see here, it's neither series nor parallel. As you can see here, the resistor R2 and the resistor R3, they are connected in parallel, and the resistor R1 is connected in series to that combination. So we can say this is a combination of parallel and series circuit. So let's say you have been given any of these circuits. Do you know what all questions that can be framed from these circuits? If you know all that question, I'm sure you will also know how to find them. So knowing the question is very, very important. So let's explore and find out what all questions that can be asked based on these circuits. So as you can see here in the next screen here, the first question is to find the total resistance of the circuit. Now this can also be called as equivalent resistance. So the question can be find the equivalent resistance of the circuit. I think you all are familiar with this. Now the second question that is very important and that is always asked in the exam is to find the total current through the circuit. The third is to find the current in each resistor, and the fourth one is to find the voltage across each resistor. Here there is a small grammar that we should take care of. We always say current in or current through, and we always say voltage across each resistor. Okay, so please take care of this grammar. Now that you know all these four questions, I would say learn all these four questions by heart. They are very simple. Now that you have learned all these questions, how are you going to apply this in the numerical? So let's say you have been given a series circuit. So what you are supposed to do, just apply these four steps. The question number 1, as you can see, I have replaced it by step 1. Question number 2 is replaced by step 2. Question number 3 by step 3, and question number 4 by step 4. So you can remember these four questions as four steps. Number 1, 2, 3 and 4. So in case of a series circuit, you have to simply start with the first question, that is to find the total resistance, then find the total current, then find the current in each resistor, and then find the voltage across each resistor. That is step number 1, then 2, then 3 and then 4. Whereas in case of parallel circuit, we will start with the step 4, then step 3, then step 2 and then step 1. Well, this is not a fixed or a rigid rule. We all are flexible to solve our own ways, but this is very, very simple and you will never find yourself stuck in the question. So this is the flow of solving the question. Now, what is important to remember is that in case of series circuit, we always solve number 3 and then number 4. What is number 3? We find the current in each resistor and then find the voltage across each resistor. Whereas in case of parallel, we solve and or find voltage across each resistor and then find current in each resistor. This is what we have to take care in series and parallel circuit. And step number 1 and step number 2, we can solve it at any given time. Okay, there is no fixed rule when to solve step 1 and step 2. But I would suggest just follow the sequence 1, 2, 3, 4 in case of series, and for parallel, start with 4, 3, 2, 1. You will never miss any given question in the exam. So now with this concept in mind, let us do some practice questions. So we are going to start with the simplest circuit of all, and that is series circuit. So as you can see here, we have got three resistors R1, R2 and R3. They are connected in series. And we also know the 4 questions that we have to solve. So let's see how we can go and do it. So we remember for series circuit, we follow the step 1, then 2, then 3, then 4. So what is step 1? Step 1 is to find the total resistance. We know the formula already. Rs is equals to R1 plus R2 plus R3. Okay, since there are only 3 resistors, I'll stop at R3. I'll not write further. Now, step 2 is to find the total current. How do we find the total current? We can use Ohm's law. From the Ohm's law, we have the formula I is equals to V over R. Now this R that we see here is the total resistance that we have calculated. So we can write this as Rs. Okay, this is important. Now, step 3. The question says find the current in or current through each resistor. So the important concept to remember is that in case of series circuit, we do not have to do any calculation for the current further. Whatever current we have got in the circuit, same current will be there within the each resistor. So remember the concept, in series circuit, current remains same through each resistor. So we can write this same current here for all resistor. And the last question, that is to find the voltage across each resistor. So we need to find the voltage across R1, then voltage across R2, and then voltage across R3. So again here we are going to use Ohm's law. We remember the formula to find the voltage, V is equals to I into R. But here we have to find the voltage across resistor 1. So I am going to write R1. And the voltage across resistor 1, we are going to call it as V1. Similarly, in order to find the voltage across resistor 2, we'll use the formula V is equals to IR, but we will use the subscript 2 to denote the resistor 2 and the voltage across it as V2. And third resistor is R3, so we can find the voltage across third resistor as V is equals to IR. We can write the subscript 3 and 3 to denote that this is the third resistor and this is the voltage across the third resistor. So you can see very simple steps. We find the total resistance using this formula, then we use Ohm's law and find the total current. Then the same current flows through each resistor in series circuit, and then we can again use Ohm's law to find the voltage across each resistor. V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. Okay, what is important to remember again here is that you can see current remains same in the formula. There is no change in the value of current. The current that we have calculated in step 2 will remain same in the question now. Okay, so let us do a numerical based on it. Now let us do the first numerical. So in this numerical, as you can see, the question is to find the total resistance and to find the total current. And here we have been given a series circuit where we find the resistor R1 resistor R2 and resistor R3, they are connected in series. So the first question is to find total resistance or equivalent resistance. So we can use the formula Rs is equals to R1 plus R2 plus R3. We can put the values from the question. This is 2 ohm plus 3 ohm plus 5 ohm. If we add them up, all we get 2 plus 3 plus 5, that is 10 ohms. This is the equivalent resistance. Now, what do I mean by this? These three resistors R1, R2 and R3 can be visualized as a single resistor of 10 ohm. So we can think of this as a new circuit where we have only single resistor, that is 10 ohm. Okay, this is called the equivalent resistance, equivalent of R1, R2 and R3. Now in this circuit, the voltage that was supplied is 20 volt, that you have to consider same. So this is a new circuit where we have only one resistor and one source that is supplying the current. So here we can apply Ohm's law and find the total current. So we can say here I is equals to V, that is the supplied voltage, divided by the equivalent resistance that we have just now calculated. So we can write V as 20 volt and Rs is 10 ohm. So we can put the value here and then calculate. 20 by 10 is 2 and this will be 2 ampere. So this is the total current that is flowing through the circuit, and we can write this as 2 ampere, and here also we can consider the current is flowing as 2 ampere. Now let us solve question number 3 and 4. So as you all remember, the question number 3 is to find the current through each resistor. So here we have got 3 resistor. So we have to find current through R1, then current through R2, and then current through R3. And then we also have to find, voltage across R1, voltage across R2, and voltage across R3. So these are the questions I'm talking about. Okay, so how to find the current through each resistor? Now in case of series circuit, you don't have to do any calculation. Whatever current you have got in step 2, the same current will flow through each resistor. This is a concept that we have to remember in series circuit. In series circuit, current remains same in each resistor. So the current, we all remember, this was 2 ampere. So we can see here this is 2 ampere. So the same 2 ampere will be flowing here through R1, then through R2 also 2 same ampere, and through R3 also same 2 ampere will flow. So the answer will remain 2 ampere, 2 ampere and 2 ampere. Now we need to solve voltage across each resistor. So what is the voltage across R1? So the voltage across R1, for that also we can use a Ohm's law, that is V is equals to I into R, but we will write V1 and R1 because we are talking about resistor 1. So we can put the value of I and R. I is 2 and the value of R1 here is 2 ohm also. So current is 2 ampere and voltage is 2 ohm. So we can put the value 2 into 2 and the answer is 4 volt. That is the voltage across resistor R1. So you can see I'm using 2 arrows. Now let's find out the voltage across R2. So we can write the formula V2 is equals to I times R2. So here 2 denotes the resistance 2. We can put the values, same current 2 ampere will flow here, 2 ampere, and the value of R2 is 3 ohm in the question. So we can write this as 3. So 2 times 3 is 6 and that's 6 volt. So here we have got voltage across R2 as 6 volt. Now let's find the third one, voltage across resistor 3. Same formula, V3 is equals to I R3. The value of I is 2 ampere and the value of R3 is 5 ohms. So we can write this as 5. So 2 into 5 is 10. So this is coming as 10 volts. Okay, this is what we have got, voltage across each resistor. Now this question is done already. Okay, so before we go to the next question, let us see this answer carefully. You will find something interesting here. When we see the voltage across R1, R2 and R3 and we add them all, let's say this is V1 plus V2 plus V3. Let's add all these values. V1 is 4 volt, V2 is 6 volt and V3 is 10 volt. When you add them all, you'll get the same 20 volt that was supplied. So from here you can check whether your answers are coming right or wrong. So this is a very important concept in a series circuit. The first one we know already, in series circuit current remains same, and the second important concept what we should always remember is that in series circuit the supply voltage gets divided proportionally. Here this 20 volt got shared by 3 resistors in a proportion according to their value of their resistance. You can see 4, 6, 10. They are not equal, but they are in proportion to their value of resistance. So this is all about numerical 1. Okay, let's do another question where we have 3 resistors again, and 4 resistors, and let's do all the 4 questions once again. So I hope you all have understood the question number 1. So before you proceed with the video, I will suggest you all to give a pause and try this question on your own and then verify the answer as I solve it. Okay, so I'll wait for a second. I want you all to pause it right now. Okay, I hope you all have solved already. So let us now verify the answer. The first question is to find the total resistance. I'll solve in the same manner, step 1, step 2, step 3 and step 4. So the first is to find the total resistance. So I can see there are 4 resistors. So I can write R1 plus R2 plus R3 plus R4. So let's add all the values. We have got 3 ohm plus 5 ohm plus 4 ohm plus 12 ohm. So how much is this? 3 plus 5, 8, 4, 12, and again 12 is 24 ohms. This is the total resistance of the circuit. So as I've told you again, this circuit can be now seen as a simplified circuit like this, where we have got only one resistor, and this is called equivalent resistance, but its value is now 24 ohm, and the supply voltage remains same, 12 volt. Okay, this is the first part of the question. Now the second is to find total current. So how do you find the total current? So when you apply Ohm's law in this circuit, you can see the two values are given, voltage and resistance value is given. We have to find current. So we can use the formula I is equals to V by R, but in this case, this is the RS, the equivalent resistance. So we can put the value here. V is given 12 volt and RS we have just now calculated as 24 ohm. So 12 over 24 is half, or 0.5 ampere. This is the value of current that is flowing in the circuit. So here we can say this is I equal to 0.5 amperes. So this is part 1 and part 2. It will hardly take any time. Now let's move to question number 3 and 4. So we all remember what we have to find. We have to find current through each resistor. So here we have 4 resistors. So we have to find current through resistor R1, current through resistor R2, current through resistor R3, and current through resistor R4. Similarly, in question number 4, we have to find voltage across R1, voltage across R2, voltage across R3, and voltage across R4. So these all questions we should be able to solve given a circuit. Okay. So this is going to be easy. Just now we have calculated the current that is flowing through this circuit is 0.5 ampere. So the same current will flow through the circuit. This is the concept what we have just seen right now. So the same current, that is 0.5 ampere, 0.5 ampere, 0.5 ampere, 0.5 ampere. So question number 3 is also done. For step 3 here, you don't have to do any calculation. Just apply the concept of series circuit, you will have the answer. Now, little bit of calculation required for step 4. We have to find the voltage across each resistor. So here we have got 4 resistors. Let us calculate voltage across R1. That will be V1 is equals to I into R1. So we can put the value 0.5 into R1 is 3. So 0.5 into 3, that is half into 3 will be 1.5 volts. What about voltage across R2? We can use the formula V2 is equals to I into R2. We can put the value of I as 0.5 and R2 will be 5 volts. You can see in the question given here. So this will be 0.5 into 5 is going to be 2.5 volts. Let's find the resistance, voltage across resistor 3. Same formula, V3 is equals to I times R3. Value of current 0.5 ampere and resistance value in the question is 4 ohms. So we can write 4. So half into 4 is going to be 2 volts. And the last one, we have to find the voltage across R4. So we can put the values here. V4 is equals to I times R4. So I is 0.5 into R4 is going to be 12. So half into 12 is going to be 6 volts. So this is it. We have done the question. But again, before we jump into the next question, we should always verify our answer. So let's check our answer. So what we do here, add all the values of V1, V2, V3 and V4. Okay, V1 was 1.5 volt, V2 is 2.5 volts, V3 is 2 volts, and voltage across R4 we have calculated this as 6 volts. So if we add V1 plus V2 plus V3 plus V4, this is going to be 1.5 volt plus 2.5 volt plus 2 volts plus 6 volts. This is going to be same as 12 volt, which is the supplied voltage. Okay, so this is correct then. So this is a way to solve a series circuit and to verify your answer. I hope you all have understood the key concepts of the series circuit. So let us have a quick recap. In series circuit, we start with step 1, that is to find the total resistance of the circuit. Then we find the total current of the circuit. Then we find current in each resistor, and then we find the voltage across each resistor. So for this given series circuit, we have calculated total resistance as 10 ohm, total current as 2 ampere, and this same 2 ampere current is going to flow through the entire circuit. Okay, the value of current is not going to be changed. Step number 4, as we all remember, is to find the voltage across each resistor. So here we found the voltage across R1, it is coming as 4 volt. Voltage across R2 is coming as 6 volt. Voltage across R3 is coming as 10 volt. The key concept is when we add the three values 4 volt, 6 volt, 10 volt, it is coming same as 20 volt, which is the supplied voltage. So let's conclude today's session with the two key concepts. In series circuit, current remains same, and in the series circuit, voltage is divided proportionally. I hope you have enjoyed today's session. In the next session, we are going to solve parallel circuits. So till then, bye bye, take care, happy studies.